Nigel Griffiths. I work in the Advanced Technology Centre here in the UK, part of IBM Europe. This movie is about a tool called nmon. I'm the originator and developer of this nmon tool. I have been for 10 years, and we make it freely available to any AIX customer. We're going to first of all download it from the web. We'll install it onto an AIX machine, which is very simple, and then we'll use it in two modes. First of all, we'll look at it on the screen, moment by moment, what the machine is actually up to. But we can also capture a data file, and we'll do that, and then take that data file onto our PC, and we'll use the nmon analyzer, which is an Excel-based spreadsheet, to analyze the data we've captured and to draw us lots of graphs, and then we can get a better view over time what the machine is actually up to.
So how do we get hold of nmon? If we go to Google, search for nmon. The first two hits are for two nmon articles, one about the performance tool itself and one about the analyzer spreadsheet. The third one down here is the AIX wiki site, where we'll find the nmon details. So here's the nmon page, general information at the top, some documentation. It's a little bit crushed here because I'm only using 800 by 600 to make the movie quick. But if we scan down here for the stable release, here is the download file for nmon 12. We click on there, save it as a file, already saved. Then we can transfer that file to the AIX machine, but don't forget to transfer it in binary mode. We don't want to have it treated as text files, or it just won't work when we get there. So here we are on the AIX machine. We've got a couple of files in the local directory. The important one here is the nmon download file. It's a GZ file, so that's GNU zip, so we're going to use gunzip to uncompress the file. So we have a tar file, and let's extract that. We can see we have a little file here called nmon. There's actually a shell script, and here are the binaries for each different version of AIX that needs a separate binary. If we just have a quick look at the nmon script, it's using this command OS level to work out what level it's on, and then deciding which version of nmon to run. If we run that here, we can see we're on AIX 6.1, TL0, and here Service Pack 5. So let's just start nmon up. Well, we're a root user, so we need to explicitly give it the file name. Immediately we can see which version of nmon are running and which version of AIX we're on. That's down here. We can see we've got two CPUs, it's a Power 6 machine, 64-bit kernel, we've even got the serial number and the logical partition name down here. If we hit H, we get a whole load of hints here of all the things that we can actually monitor. And all of these things toggle on and off, so if I hit H again, it will disappear. The common things you want to see are the CPU. We can see the numbers here for how busy it is, and we get a graph telling us what's going on. U is for user time, S for system time, W for wait time. And if we hit C again, it will disappear. We can look at M for memory. We can see the stats here. Or if we hit C, we'll get both of those. We can look down the bottom here that things are sliding off the bottom of the screen, so we can actually grow our window a bit larger. We can then perhaps add some more stats, so N for network. And after a couple of times with no errors, that bit gets switched off. We can add D for disks. There's a hint coming up here that we have to run this command as root if we want to switch on the percentage busy. So I use Q for quit. I'll run that command. Start up nmon again. CPU, memory, network, disk. Now we can see the disk stats down here as well, so we're doing quite a lot of writing onto HDisk 0. I'm actually running some workloads to generate some CPU and disk I/O. We can see here we have the physical memory and the paging space. So the paging space is only 1.8% used, and we've only got 2% of memory that's actually free at the moment. Let's switch off the memory and network here, and I'll hit T for top processors. So we have a list of top processors running here, and we can see that these N commands here, nCPU and nDisk, are what I'm using to generate our workload. Now there's a whole lot of other things we could actually monitor, like the journal file system, what's happening there, or P for the partition information. So we have a lot of information about our entitlement. Here we're 10% of a CPU and how much we're actually using. We're using 0.6, so we're running at 600% of our entitlement, for example. We see lots of other details in here as well. So then we can use this mode of operation to investigate what our machine is doing right now. But well over half of our nmon users are actually not using this mode of using nmon. They're actually using nmon to save data to pull into a spreadsheet and analyze the graphs of what happened over an hour or a day, for example. So how do we do that? Let's quit and clear the screen. If we run nmon again, but this time we put in a few options, minus F, which is going to save it to a file. I'm going to use capital T to gather some information about top processes and their user arguments. That's a capital T. Then a little bit like vmstat and iostat, we have to say how many seconds between each snapshot. So let's do 5. And how many snapshots, how count do we want to run? So we'll actually do 300. Somewhere between 300 and 500 tends to draw a good graph. Now you'll notice that we drop back to the shell here. nmon's running in the background. If we do a ps command, you won't actually see it there. It's because it's made it itself into a daemon, so that if you logged out of your machine, then it will carry on running. It won't stop because you've logged out. If we search all the processes running, we can see there it is, nmon gathering data in the background. If we look at our, let's try again. If we look at our directory listing here, this is my machine called Bronze LPAR2, and this is the nmon file here. And we also have in this title the year, month, day, and the time that we started nmon. This file name has been very specially selected as particularly useful, because if you have a directory full of these things, you'll have them by the particular host name, then in the order of the date and time. So you can quickly look through your files in a particular directory. A lot of people try and change the name, but I think we actually got a good name here as default. Now I'll let that run. It's going to run for quite a long time. It's going to run for 300 times 5 seconds, and I'll change some of the workload as it's running so we have some graphs that will look more interesting. I'll stop here and we'll pick it up later on. The nmon recording is finished. It's created this file at the top here. It's 390k for those 300 snapshots or so. If we actually edit that file, we'll find it is a text file. There's nothing strange in here. And there's various sections. You can see here that these lines start AAA. This is as you start up. It captures what it intends to do with the machine that it's running on. Further down we have these BBB sections, and this is the configuration is snapshotted and saved into the file. You'll see that there is all these various items are comma separated because this is a comma separated values file, the sort that you can pull into a spreadsheet, and each of the different values go into a different cell. Now if we go down here a little bit further, we'll find many more BBB sections, some of the kernel parameters, details about all the disks. Let's search for the ZZZ section. So here's the last of the configuration and parameters being saved. We output one of these ZZZ lines. This says this is snapshot number 1, and this is the time that the snapshot was taken. And then we see it goes through the CPUs, logical partition, memory pools, memory data down here, paging spaces, the process information, files, network stats, journal file system. We go further down here, it's all the disks, and then there's another one here that it will be 5 seconds later in this case because we're snapshotting every 5 seconds. Now if you sorted this file, you could actually pull this in because it will sort on these columns in here, and so all the CPU lines will be together in a block and all the LPAR lines will be in a block, and you could simply pull it in and then start drawing graphs. But that's what the analyzer is particularly good for. So I'll FTP this file to my workstation, and we'll use the analyzer to draw us the graphs of the data we have in here. One final thing is here we can see this is the top data in here. So this is a process called nCPU, another one here called nCPU. If we move on slightly, we can see another program in here called ndisk is running. And we're capturing in this uargs here the user arguments. Normally we just have the process name in here. And these numbers across here will be the amount of CPU and memory that this particular process is using. We should find that in the graphs in a minute. I've downloaded the analyzer, you can see it sitting here, and unzipped that file. This was on the same website as the nmon itself. The nmon page has a link to the nmon analyzer, or you can use Google to find it. So, and here we have our data file that we captured a few minutes ago. So I'll start up the analyzer. I'll have to enable the macros, and I'll resize it to get it onto the movie. So this is starting up. If we press this button, it'll ask us for which file we actually want to monitor. In here we have an option here called the pivot chart, and it's set to no. I want to set that to yes. That'll draw some extra graphs at the end, but it does make the output file quite large. So we'll now select here, and we have to go and find our file, nmon data, ABC, and here's our file. So I'll just say open for that. It'll go through that file, then analyze the data and draw the graphs automatically for us. It's asking me to save that file. Yeah. By default it just puts XLS on the back, so that will do for now. It's saying here that it found some lines in here it didn't like, so it's going to ignore those, and it's drawn the first set of graphs for us. This is a summary of both the CPU in dark blue here and the I/O, so we can see the relationship between high CPU and high I/O. Now in my case I was running a program that generates disk I/O, a different program that keeps the CPUs busy. Along the bottom here we have the various sections of data, B for disks, C for various other things in here. We can look along these. Let's move this out of the way. If we look at the logical partition details in here, we can find out the physical CPU use and how much the entitled was. I was entitled to 0.1 of a CPU and I was using nearly the whole CPU for a large piece of the time here. If we scroll down we can find other graphs about the utilization during the capture, and how much of the shared pool we're actually using. We were limited here by the number of virtual processors was set to 1, so we can only maximize one CPU. If we look at these other things in here, we can see what the CPUs were up to. We have a disk summary, both the IOs per second and the read and write numbers in here. We can see which disks were busy. We've got things like block sizes, disks per busy. I've only got one disk, so that's quite a simple chart in here. But read and write for the disks. We've got the file IO. This is the read and write counts going through the read and write system calls in here. The iget and name_i are calls to the kernel that actually does directory lookups. We've got adapters in here. We only have a virtual SCSI adapter. This is a virtual IO server client logical partition. Here's our file systems. We can see I created a big file in the file system here in home, and it got to 100% during the run. We have memory statistics here, how much was free. It jumped up at this point. Memory use, so we can see the system memory, what's been used by the processors and what's been used by the file system cache. If we carry on over here, we have the network statistics, the read and write rates. Here, this can help you decide whether your logical partition is receiving data or sending data. We've got packets and sizes. We have paging. Well, no paging going on. It's a very simple logical partition. We've got things about the memory pool in here. Process stats, how many processes we're starting and stopping. We can see the run queue here got to 25 processes running at one time. So we can see here the nCPU, unsurprisingly, was taking up most of the CPU. That's the only job of that program. Although we can see NDisk was taking a little bit of CPU time. And we can see down here the memory used by commands and the amount of I/O being done by different commands. NDisk scoring here because it's just doing disk I/O. We have the user arguments in here, so we can actually find the full arguments of the commands we're actually running. If we look at this one, this is the pivot chart, telling you which process is taking most of the CPU here. So it's the nCPU program, as we might expect in my simple case. Well, we can look at these charts in greater detail in other movies. That brings us to the end of our movie, looking at nmon and getting you started. We've looked at how to download it and install it, how to run it immediately online on the screen to get a feeling for what your machine is doing right now. We've looked at how to capture data for a longer period of time, and then how to graph that with the nmon analyzer. There are other ways that we can graph data. We'll look at those perhaps in later movies. If you have any questions or any suggestions for nmon, then please go to the forum. You can see the website here and look for the Performance Tools forum, and you'll find a lot of questions there about nmon and performance on AIX machines. I hope you have as much fun using nmon as I do writing it.